Step 2. To support your skyscraper, build a reinforced concrete superstructure.
The concrete core spans the entire height of the skyscraper. It acts kind of like a big spine, but it's surrounded by steel, so they both work together to keep building up. You wouldn't be able to build a skyscraper without steel.
Steel is a wonderful building material. If you stretch it, it will restore. And if you overbend it, it will restore. Now, the real magic of steel is that putting it together with concrete, you have reinforced concrete. And thermally, steel and concrete grow and contract at exactly the same rate. It is an ideal composite.
Coming off this core in the middle are outriggers of steel that create triangles for extra stability.
Install a hollow concrete core with walls that are 4 feet thick at the bottom and 2 feet thick at the top. Erect vertical support columns around the perimeter. Connect outrigger support braces to form triangles between verticals and core every 25 to 30 floors, as well as horizontal supports.
The horizontal pieces are critical to stabilizing the sway of the structure. If we get very tall vertical pieces that are not cross-stabilized, you can get things out of alignment.
In the safety of our laboratory, we can observe the consequences of allowing the vertical construction of your skyscraper to get too far ahead of the horizontal support elements. This outcome may adversely affect your schedule and your budget.
When you build the skyscraper, you have to build from the bottom up and from the inside out. Essentially, when you're building the building, you have to build the building so you can continue building the building.
The formwork for the core slides up as we're pouring the concrete, and we just keep sliding it. And we jump that slide every 4 days. If we can't slip it every 4 days, the delivery of the steel coming up around it will get out of sequence.
Step 3. Give your building a nice appearance.
The curtain wall, which is the outer parts of the skyscraper, that's what you actually see. So that's the part that they're going to make look really good.
The curtain wall is not holding up the building in any way. It's really an environmental skin that is aluminum, steel, and glass, which allows you to see out, and it also insulates the interior.
After restoring your skyscraper's structural integrity, attach panels of the curtain wall to the building's framework. Bolt panels to angle brackets attached to your support columns. Congratulations! Your skyscraper is physically sound and looks great. However, the building is just an empty shell. You're still 9 million man-hours from being done. Now that you've finished building the exterior of your skyscraper, it's time to turn your attention to the interior. Be sure you have included the cost of another 9 million man-hours in your budget.
The most expensive component of buildings is time. We're talking about $1 million a day.
Step 4. Install heating, ventilation, and air conditioning.
Every part of the skyscraper has a different weather system around it. At the bottom, it may be more humid and hot, and at the top, it may be very cold and dry. So each zone has a different heating and air conditioning system called the HVAC system to control it.
The most important thing is to make sure that there's enough capacity that even the top floors receive the same level of utilities as the bottom floors.
To accomplish that, install HVAC systems in the basement, in dedicated mechanical floors spaced evenly throughout the building, and on the roof. Step 5. Call a plumber, and then call 200 more.
When you're building a skyscraper, you're gonna need a lot of pipes. You might need as much as 75 miles of pipes just for the sprinkler system. There is a myth that if everyone flushes their toilet at the same time in a skyscraper, the building will collapse.
There's no chance that the building would ever collapse. The plumbing system in a skyscraper, it redistributes all the piping, so no danger of a catastrophic collapse due to simultaneous flushing. Like, okay, cool.
To distribute the stress equally, install a multi-zone plumbing system with pressurized water tank, calibrated for each system.
Vertical piping is a very big concern in tall buildings. If you have a column of water and it's a foot tall, it weighs a half a pound. If it's 10 feet tall, it weighs 5 pounds. If you have 1,000 feet, that's 500 pounds of water. If you turn the tap on a 500 PSI, it will cut you like a knife.
That's too high of a pressure. So you have different elevations in the building where you pump your water from.
Step 6. Install vertical transportation.
If you're building a 490-foot building, you can't expect people to take the stairs.
Yeah, for some reason, there's still 6th-floor walk-ups in Manhattan. Why does that exist?
So the elevators in skyscrapers are located in the concrete core. And the reason why is because, first of all, it's the most stable place in the entire building. And secondly, because it's such a massive amount of concrete, it dampens out the vibrations and the noise. Otherwise, it would be very, very loud.
Install electric motors to power high-speed elevators operated by a pulley system, consisting of a cab and counterweights on a cable.
We accelerate the cabs so quickly and decelerate them so quickly through the 850 feet of this core that people standing in elevator lobbies would be subjected to a massive pressure when the elevator doors open that could blow people over. So we have to design it like we would a missile in a missile silo. We put a fiberglass nose cone on the top and on the bottom of each elevator because the pressure occurs not only when it's going up, but when it's descending as well.
Step 7. Keep your skyscraper standing.
All in all, your building's going to weigh 3 to isolate the building from the shaking ground. These isolation systems are flexible bearings that allow the building to slide side to side, and so when the earth moves underneath it, it doesn't shake.
But when you get to super tall buildings, wind is more dynamic than the seismic. We want the building to move because as the building moves, it's absorbing the energy. We just don't want the movement to start running away. So we put tuned mass dampeners, a massive weight on a pendulum hanging at the top of the building, that when the building hanging at the top of the building, that when the building
For the sky.
With all of this exciting competition and new technologies coming out, who knows what the future's going to bring?
They're building skyscrapers like we build Lego now. In China, they just built a 57-story skyscraper in 3 weeks because they built 2,000 prefab parts and then were able to build 3 stories a day and built this entire structure.
I know people make fun of engineers, but what we do is, it's so exciting. If you don't like to interact with people, you can just interact with numbers all day long.
It's the building block of life. It's the stuff you wash your car with, and it can provide trillions of watts of power. Talking about water, people.
How to build a hydroelectric power plant.